Hello developers, let's start developing. Today we're taking on task 10 of the Advent of Code 2025. We still not done with task 9, which is turned out to be a very hard problem. I don't have a solution, but I will try something. I have lots of ideas that will work but will be suboptimal, so there will be a lot of optimizations over there. However, let's get into task number 10. So, of course, the elves have some machines, some manuals, and the initialization procedure was written by a dog. Because, of course, it was. We have this input, and this last part is the joltage requirement, which is not relevant for part 1. This thing is. And as you can see, last time we had trivial input but a hard task. Now we have kind of a complicated input that I think I'm gonna need a regex to actually parse. So what we have, we start with our, oh, that's an end. We want to start, and then we have the literal that thing, and then, are we in ECMAScript? Yes, so we get a correct thingy for this. So then we have that, and then we have literal dots or dashes, hashes, and we have that more than one time. And then we have a literal thing like that. So now we need to find some groups. You can see that this thing matches the first dot, the last dot actually, only because this group happens multiple times. So I will turn that into a non-capturing group, and then I will actually capture all of these matches. So we get those dots, and those dots on hashes represent lights that are initially on or off. Dot is off, hash is on. After that we have a space. After that we have something like this. So it's a literal open parenthesis, and of course these symbols were selected because they're also used in regexes, so whoever uses regex to parse this will need to escape a lot of things. And then we have some digits, maybe more. Do we have digit 10? Let's see if we have 10 over here. Seems that we only get up to 9 lights, which is okay, but still doesn't hurt. Let's say it could be more than one digit. And then we have a group of maybe once, maybe multiple times, maybe zero, maybe many times, of a comma followed by some digits. And again, this is another non-capturing thing, so we don't want to capture the last digit. And at the very end we get a literal closing parenthesis. So that is one of them, but we might have more of them, which means this whole thing can be followed by a space and that whole thing. And of course I'm missing a slash over here. And this thing can also happen multiple times. So this should also be non-capturing, but this whole set should be capturing. And we're gonna use maybe another regex to actually extract the matches after this. So now we have the first part, the second part, which are the buttons. Each button when we click this button, it toggles the third light, this toggles the first and the third one, and so on and so forth. And then we have a space, and then we have that thing, which is not a special thing in regexes, so we can just write it. Isn't that awesome? And then we have some digits, and here we can have multiple digits. That this thing, yeah, I'm gonna straighten that this is a non-capturing group. That is gonna consist of a comma followed by uh, some digits, the other kind of slash, and this can happen multiple times, which is followed by that sign, which is followed by an end of string. And all of this I want to actually capture. So the first match captures the light pattern, the second matches the buttons, the third one matches the joltage things. So this beautiful thing is our regex. Never write regexes inside your editor. Some editors have better regex support, but I will always define a regex here, even if it's less complicated than this. But because it doesn't really matter. We want to be able to test it, to manage it, and once we paste it, it doesn't really matter. It will match because we already tested it here. So don't test it over here. Anyway, oh, also make sure to put it in the right method. So let's type our input now. So our input will be not an input, but what is this thing? A machine. I am machine. So it will have the lights, which is a, we can use a string, we can use an array of dots and hashes. Yeah, let's be pedantic. So this will be a dot or a hash array. We have the switches, the buttons. And we have the, it doesn't really say, the joltage requirements. That is an array of numbers. So the buttons are an array because we have multiple buttons, but each button is also an array of numbers. So now we're gonna read that, and lines.map. For each line, we're gonna match it. If we have a match, then maybe something like this. If we don't have a match, we don't even need an else here. Yeah, let's zoom it a bit. Yeah, this is enough. So I like having a throw at the end, just like this. This closes that, that closes that. So these are the machines. Let's now verify that this is what we want. So we're taking the first match, which is the lights. We're splitting them on every character, mapping them like that, and they go into the lights. That's great. We don't need this thing. It should just work. Without that, it recognizes it that it has the same format, but it doesn't call it properly. Because, yeah, we're not gonna use a string num array, we're gonna have a machine array. Everything is just fine. I'm not sure about the second one. It says split it on a space. Is that what happens? Split it on a space and then we get these things. Slice off the parenthesis, split on and map it using a number. Let's see. Let's see. So we need to find our input. That's for day 9. For day 10, it will be something along these lines. So if we run this, and of course we're gonna run it in debug mode first so that we can see the input. So we had the lights. The lights seem okay. Yes, then we had the lights are okay. The voltage requirements are not okay, because this is supposed to be 3 and this is supposed to be 7, so we somehow the middle digits are correct, but this is 10, this is 5. We're messing up the corner ones. Is our regex okay? Let's see. It says 3547. It says yep and yep. So which means it's our code. Let's go back to the code. Oh, it slices off the last things. We are already slicing that off because we're in the regex itself. So yeah, always check code that was generated for you, because you didn't write it. You have no idea. I mean, if you do write it, please check it again. Otherwise, you might make bugs. That's great, that's cool, only I don't see the buttons here, so I will just say, well, show me the buttons. So of the input, map it so that only the buttons remain. This will be an array of arrays. Yep, so we have that 3 1 3 2 2 3 0 2 0 1 and finished 2 0 2 3 4 2 3 0 4. Yeah, so it seems that the first hard part is done. We didn't got any errors. Let's just check it on the big input, if this thing will error out or actually give us some data. It gave us some data. I'm not gonna doubt it unless we get an error, in which case we will try to see what's going on. So let's go back to the small input, and now the good news is that all of these are independent cases. So if we solve this, we're done. If we solve with this, we're done. So basically our code will mostly be like this. Let total button pushes. I think we're correcting how many total button pushes we need in order to light everything, but we need the minimum. So total, yeah, that's 0 for each machine for input. We're gonna say machine dot, and now we're gonna extract this into some kind of a method, not print machine, but calc button presses. We get a machine and we return a number. This returns 0, but that doesn't matter, because for that machine we're just gonna calculate it, add it to the total. Let's do this in 2 lines because we might want to debug later. Machine pushes. For that machine we get that many pushes and add it to that, and then at the very end we just return the total number and we're done. Sounds simple. Well, usually it can be simple once we get to a point when we are kinda understand what is going on. When we drill this down to simpler problems which we can actually solve. Because usually we cannot really solve a huge problem, but we can solve a tinier one. So now our tinier one is that for a given machine that happen to be here, is correctly configured, everything is okay. We have no idea within this method how the parsing was done with that monstrosity. So we're not looking at the monstrosity, we're just focusing on a simple machine. And now my reasoning is this. We're gonna need some recursion here. So I'm gonna do a kind of a brute force. I'm gonna try all the possible combinations. On the other hand, since these buttons, one press of the button will turn some lights on, will toggle some lights, which means another press of a button will toggle them back again, which means that we're gonna push each button up to once. So we either from, if we have 10 buttons, we can push those buttons or we can just not push those buttons. Those are the options. So now we need to find out. So for if we have 10 buttons, then it means that we have 1024 options of pressing, because we can press none of them, we can press the first one, press the second one, press the third one, press the first one and the second one. And if we write that like a binary number, for example, yeah, for 10 bits, yeah, we can do it like this. Each of these bits represents whether we push it or not. So this would mean that we push all the buttons, this would mean that we push all the buttons except the second one, and so on and so forth. And all those zeros would mean that we don't push any of the buttons. So let's make another method. We might integrate them later, but it helps me think. So we're gonna have a method, yeah, push button. We have a machine and we have an index. And then we're gonna return another machine. Actually, we don't care about the machine, we care about the buttons and the lights. Yeah, we're gonna need a machine. Do we? So this returns another machine. So let's create another function, copy machine. Yeah, this is relatively easy to auto-generate because it does exactly what we want. So we make a new machine, we get the button of the new machine, we are looping through the button. For each light index that's in the button, we don't need this if because we know that we are gonna behave. Yeah, we toggle the button and then we return the new machine. So we push that button. So from 0 to not max voltage to 2 to the power of number of buttons minus 1. Yeah, so that is the number of combinations that we have. Num buttons, yeah, okay, we can do that. Let's see if this thing works. I have no idea what this did, but we're gonna read through it and try to understand it. I know what I wanted to do. So basically I want to do a loop from 0 to the maximum number of combinations, and through each of that see how many presses are actually needed. And note that we need a minimum. So we might want to reconsider something like this, because this kind of goes linearly. So if we have 10 buttons and only the 10th button needs to be pressed, that means that that's the 512th, 13th combination that we're gonna check. And all the others are right. So if we can speed this up, if we order our combinations correctly, if we first check only one button, then only two, then only three, then only four, but that's kind of complicated, and we have up to 1,000 combinations, so we can live through it. Yeah, we'll call this index just for betterment's sake. So we have our test machine, we're copying the original machine so that we don't break the machine that we were given. We have current presses. Yeah, and then for each button. Do we want to go through the button? Yeah, so this is a magic line that actually checks whether that index is 0 or 1, and only runs this code if this index is 1. Yeah, let's check it with Claude, for example. What does this code do? I trust that it's that, I think that it's that, but I will check it once more. If the jth bit of index is actually set. And here we have some nice explanation why this actually works. So if that bit is set, then we're gonna get our test machine, we're gonna update our test machine, we're gonna push that button. And this is the bindex, the button index. And this is the combination. Because we're using the index not as an index, we're using it actually as a key, to a bit mask to loop into. So we're gonna push that button and update the machine, so this state gets updated. If we have 3 buttons, we're gonna push all of them, and then we count the number of current presses, which is actually equal to the number of zeros to ones that we have in our number. After everything is done, I think it got this thing wrong, because we actually need to check if all the lights are on and not all the lights are off. Yeah, let's see. The machine has the number of has the number of indicator lights shown, but its indicator lights are all initially off. Oh, so we made a mistake. Yeah, so we're not starting from this position and trying to get to everything on. We're starting from everything off, which means that this machine that we copied actually needs to have its lights off. Yep. So now we have all the lights off, I think. And after we're done, we now don't need to check if all the lights are off, but let's actually define something else. Target state is machine dot lights, not map it, but join on a nothing, and this becomes a string. And over here we can say const my current state is the test machine's situation, and if the current state is equal to the target state, we don't need this. If the target state is all the lights are off, then we're done with 0 presses. That's quite okay. So if the current state is equal to the target state, and if current presses is less than the previous number of presses, then we update that. So we're gonna assume here that this is a huge number. So we will get initialized. Otherwise, we will get 0 all the time. Oh, and that's why Copilot put on a 0 check here. So after all of that runs, we're gonna return the number of presses. So now, yeah, we call them pushes, we call them presses, but who really cares? Console log machine requires that many pushes. So let's see. Let's run this code. The first machine requires 2, the second one requires 3, the third one requires 2. Seems okay. Let's try to run it on the big. Let's actually run it without debugging once. And let's be fancy and add the console log into a debug. Yeah. Since it's only one line and it's never gonna be more than one line, we can also do it like this. Let's try it. Seven seems okay. So the moment of truth is upon us. Let's change this to the big input. I don't think that we have the dots scenario, but nobody said that it is invalid. Let's try to run it. And it says we have 469 presses for 179 machines. Kinda makes sense. It's not gonna be too big. Most of them will be 2s and 3s. And we got the right answer. One gold star closer. Let's look at why the heck we need the voltage levels. So I will read up on this and then I might be back, or I might leave this for part 2 if it's scary enough. So, good news, bad news situation. The good news is that the task is kinda understandable. So now we're continuing with the same issue, only now this part is not relevant, only this part is relevant. So we had 4 items, registers, whatevers, that initially start at 0, and we need to get them to this value by pressing these buttons. Which means that, for example, when we press this button, this register, actually 0, 1, 2, 3, this register will increase by 1. When we press this thing, this register and this register increases. When we push this one, this thing increases. So we need to determine the minimum number of presses that we actually need to do. Now, this is gonna be, I feel that it's gonna be recursive. we're gonna want to look at recursive solutions. Maybe we will want to resort them, because we want to press this button as much as possible and this button as little as possible, because this button, or over here, this button provides us with 4 units of joltage, let's say, and this button provides us with only 2 units of joltage. So in order to get this, which is the sum of everything, we would like to press this button as much as possible, or this button, doesn't really matter. So we're gonna need to do, but I have no better idea than to do some random button mashing on all of the buttons, which means that we're gonna have to go deep inside recursion, which means that we're gonna need to do some caching, because this has a huge fan out. Basically, for the first option, let's go with this, with 6 buttons. For the first option, we have one way to press them. For the second one, we have 36, and so on and so forth. Not 36, maybe less, because pressing this button and then this is identical to pressing this then this. But still, we're gonna have a lot of data. Another thing, pressing this button, then pressing this button will always be inferior to pressing this button. So if we want to press both these buttons, we can just press this. So these 2 buttons are needed because 2 and 3 have different values. We might want to actually, we cannot press this button 5 times. If we press it 5 times, this goes overboard and explodes, I guess. So yeah, it's not gonna go from 6 to 36, but it's gonna go from 6 to 20, and then from 20 to 100, from 100 to 600. So, and that's for 1, and over here we have 7 and 7, 14, 19, 20-ish steps. We will get something less than 6 to the 20th power, which is a huge number. So even if we get to 3 to the 20th power, that's also a huge number. So we kind of want to dampen down on that, to have as small a fan out factor as possible. And we will need to develop some things for that. So that's gonna be coming in part 2. For now, I'm leaving you with this solution. Don't forget to click like, subscribe, comment if you have any ideas, and keep developing.